Howdy, everybody. We're here for day 8. That's what this video is. Sorry, I'm a little behind. The cold got to me, but anyway, I'm mostly caught up. I just want to record some videos to talk about my solutions, and I'd love to see what your solutions are too. So let's just get going with day 8. I'll show you what I did. Maybe talk about the problem a little bit first. So the basically what it is you're on top of a roof and you see a bunch of antennas, and you notice that each antenna has a different frequency, and the antennas with the same frequency, meaning like these A's have the same frequency or these zeros have the same frequency, can create what they call antinodes. And it took me a little while to grok what they were saying, especially for part 2. But the gist of it is like the distance between any two nodes or antennas of the same frequency creates an antinode that much farther, like double that. So like if you can see, these are like you go over 1 and down 2. So from here you'd go over 1 down 2, and then here from here to here is up 2 over 1, so we go up 2 over 1, and it creates those two nodes. So maybe saying it's double is not the quite way to say it, but it's just like it kind of extends in a line 1 out for part 1. And so the idea is, so here's an example. Given 3 nodes, right, you can see you create this line, and then you create this line, and then you create this line. The ones out here happen to be off the grid, so you don't count them. Let's see. So, I mean, is this too loud? That was the gist of part 1, is like, you just have to figure out what those are and how they differ. So here's like the test example, I think, right here, where you can see they've created a bunch of like antinodes. And then the question is, how many unique antinodes are there? This one felt a lot easier than the previous days. I mean, I think it was literally just, can you find the difference between 2 points of the similar type, and then can you use that difference to put points as the antinodes? I think that's the way most people did it. Some people used a little bit of math. For me, it was as simple as just calculating the distance. This is a little bit like the Manhattan distance, if you've ever seen it, where like or they call it the taxi cab distance as well. The idea being you're going in like blocks, but we want to know, like, as opposed to just summing up the two differences and saying here's how far you have to go, we actually want to know how far do we go in the X and how far do we go in the Y. So I have this difference function that does that for me. Otherwise, I have a point, and then I can do that. One thing I did find useful, remember I was having problems with like enumerating, and so I was zipping with a U size so I could add that, or an I size so I could add that stuff here. It occurred to me at some point that why don't I just pass U sizes and cast them here in the new function? Then I don't have to worry about casting outside. So that's where you see it's a little bit different. When we create the map, I can now enumerate like this, and then I just create the points. I'm interested in 2 things. Obviously, I want to create the map itself, the grid. So I want to like fill all these up with their values. But then I also need to know the different frequencies and where they are. And I just do that because it's really easy for me to then like say, hey, where are all the A's? Where are all the zeros and whatnot, right? Oh, I guess it's over here. We can show it over here. So we can just show those differences, right? Or show where they are, and then it's easy for us to do that. So I actually have 2 objects in the map, or 2 data structures, and then we use these for loops. We have had problems before where it's hard for me, where it was like, how do I like use functional style methods and update 2 values? And I think it was Claude. I asked one of the AIs about it, and how would you do that? And they actually mentioned using fold to do it. So you can see I have it commented out here, and I'll have it in the code section that you can look at if you'd like to. But the gist of what's happening here is you still do the enumerates like you would up here. You just do a fold where you create the two data structures that you want to, update, and then you can fold on those two data structures, right? So you can see here as I return each of, the graph and frequencies, and I update them each separately, right? I add the point to the graph, and then I add the if it's a frequency, I add it to whatever frequency vector that is. Okay, so then I just have this function that I use to kind of help me for the two parts. What you'll notice is, like, if you think about what you're going to do, is you're going to kind of do a Cartesian product of all the A's and say for each pair of A's, can I find, their associated antinodes is what they're called, right? Can I find those antinodes? So to do that, I just wrote this little helper function that's like, okay, process the frequency pairs, because I do the same thing in part 2, but just slightly different. I'll show you. And all that does is it goes through all the frequencies and then does a Cartesian process on each of them and then calls a function that you give it. So this is like, I don't know, higher order programming is what they call it, I think. But the idea is you give me a function and I'll iterate over all the products of the same frequency, and then I'll call your function for each of them, and then I'll return the number of antinodes that were created, right? So this function's job is to update the antinodes. So down here for part 1, again, if you think about, all we're doing is we're just going to iterate through all of them and then find the antinodes. Obviously, some may overlap, right? I don't know if it's easy to find an overlap here, but you can imagine, like, the zeros may create an antinode and the A's may create an antinode, and they're both at the same place. We only want to count unique locations, as the program says. So that's what we do. We basically call that process frequencies, which is going to do that for loop. And then we give it the function that we want it to do. And what does the function do? Well, we just get the difference between the node and the current node, and we add that to it, right? To the current node. So imagine we're working on like these two right here. We take this one and this one, find the difference, and add it to this one, and that should give us this, right? That should give us here. And then we just need to do the opposite, right? We find this one and this one, and we find the difference between those two, and then add that to this one, and that gives us this. So you can see that's what we do right here, is we say, add to the node the difference between that node and the current, and then if that's on the graph, add it to our antinode list. And then we do the same thing for the opposite way. If that is on the graph, right, we want to count for the cases where, like, for example, this one is on the graph, but the one that would be over here is not on the graph. So we just we say, hey, is that in our graph? If it is, then we insert it. And then once we're done, we've gone through all of them. This will give us our frequency graph, or sorry, our antinodes. What happened there? I'm still very much getting used to VS Code. This will give us our frequency. What happened? What did I do? I did some kind of copy and paste somewhere, and it's caused a lot of problems. Is it it looks like I did this down, and where does that go? like that. Wow, I don't know what happened there. Okay, thanks VS Code. Okay, so anyway, back to where we were. We call this function that kind of does the Cartesian product for us, and then we just check to see if, hey, if I like add myself to the difference of those 2 points, do is that thing on the graph? And if it is, I insert in the antinodes. And so now, because it's a hash set, I'll have a unique list, and I can just return that as the length. So that's part 1. That's all there is to part 1. For part 2, what they say is, oh, well, it turns out that it can occur in any grid position that's exactly in line with at least 2 antennas. That is to say, like, if you think about these 2 values, it now continues to extend outward. It like, in here they call it they ask if we took resonant harmonics into the calculation, which I just think it means it's like keeps going outward, right? It keeps resonating outward is what it's trying to say. So you can see these 2 go like here and here, and then they go off the map. These 2 go here and they go off the map. These 2 go here, 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 and then they go off the map. You're doing the same thing as part 1. You just continue to do it until you go off the map, right? So that's the idea. So the question is like, my first thought was, well, is that going to how much is that going to complicate things, and is it going to cause it to be perform poorly? I just figured, though, hey, why don't I just keep trying it until I'm done, or until I fall off the map, right? For each way. And so you can actually see that's all I do here in part 2 is I just say, I do the same thing. I'm going to say, okay, give me the difference. And then as long as that difference is on the map, I'm just going to keep adding that difference to where I am on the map and just keep inserting that value. So the idea is I'll have these 2, and the difference will put me here, and I'll add that, and then I'll ask, okay, if I keep going that direction, right? Can I add here? Then can I add here? And then eventually, can I add down here? It will say no, and it won't let me add, right? So that's all I'm doing. All I really changed was this if into a while let, and suddenly I'm able to get all the nodes, right? And so now we just need to do how do we get like the sum of all these? It's a little funny because this gives you the nodes, but and originally I thought that was the end of it. I'm like, oh, okay, there we go. But then it says something in here. In fact, the 3T frequency antennas are all exactly in line with 2 antennas, so they are all also antinodes. And that really threw me for a loop. And I think looking at like other solutions and other people's comments about it, that kind of threw them for a loop too. Essentially what that's saying is any node pair like this also means that these 2 should be included in your count. So for me, day 8 was all about, can you grok what they're trying to say and get to the answer? If you look, the code here is not too crazy. But what it means is, once I get this solution from part 2, I've now created all these hashes per se. But now I also need to include like any of the A's. As long as there's more than one A, I need to include all the A's, if that makes sense. And so the way I do that is I just take I take the antinodes that I've created from the process frequency pairs, and I extend that by looking for nodes in my frequency list where there's more than one node in the list, and then I can just add those up. I just get a lane of those because those are included as well. Those should be included as well. And notice this is all, you may be saying, oh, how come you can just extend your answer to P2? And that's because P2 is actually a hash set, right? So it doesn't, I just add all the nodes in there. If they're already there before, if they've already been put in previously, that hash set takes care of it and ensures that I have like a unique set of the antinodes, if that makes sense. And so that was it for day 2. Again, just like to recap it, or day 2, for day 10, part 2. Just to like recap at a really high level, I don't think there was anything particularly complex here. You could argue that this was another brute force day because you're essentially just going through all the points and then figuring out how far you can extend them, or just extend them once for part 1, and then for part 2 is how far can you extend them. And you just kind of go through the list and do that. It's one of those days, and this happens all the time. There's the instructions at least aren't clear to me, and so you kind of have to grok it and you mess it up, and it doesn't quite make sense. And so it didn't. It took me a little while, and so like part 1 wasn't tough, but part 2, missing this part where I say, okay, I also have to include the antennas themselves in the count. That's what got me there. So I believe this will give me the right numbers, right? Because I did just dork up the code, but yeah, that gives me the two good numbers. And I think what the reason why is, like, when I was first testing, and it said, oh, it now has the original example has 34. I was getting something like 29, but when I added them up, I'm like 1, 2, 3, 4, 5, 6, 7. So 29 plus 7 is 36. Why do they say 34? It took me a little while to be like, oh, it's because there's some overlap, right? It's like some of these will be counted twice, and when I uniqueify it, it will get me down to 34, and that's where this part helped right there. So yeah, feel free to share with me what you got. Right, I've been really enjoying some of your solutions, especially in languages that like I'm less familiar with. It's fun to see how you did it, and maybe the cool ways that you did it. So keep doing that. You can either share it in the comments below, or take my gist and just fork it, and then I believe I can see your forks and stuff like that, so that will allow me to look at your code and what you did. So there you go. That's day 8. Not too tough, not anything crazy that some algorithm that you needed to know about, but definitely just one of those read the instruction days. Okay, I'll see you in the next video for day 9.